Understanding Scikit-learn Gaussian Process Kernels, a comprehensive guide. The Scikit-learn sklearn library provides a powerful framework for working with Gaussian processes. GPs through its Gaussian process regressor and Gaussian process classifier classes. At the heart of these models lies the concept of kernels, which define the similarity between data points and shape the resulting GP model. This guide dives into the world of sklearn Gaussian process kernels, exploring their functionalities, key parameters, and how they influence the resulting model. What are Gaussian process kernels? GPs are non-parametric models that essentially draw a continuous function through data points. The function's smoothness and shape are governed by a covariance function, commonly referred to as a kernel. Here's how it works. 1. Kernel function. The kernel function takes two data points as input and outputs a value representing their similarity. A higher value indicates greater similarity. 2. Covariance matrix. The kernel function is applied to all pairs of data points, creating a covariance matrix. This matrix describes the relationships between all data points. 3. GP model. The GP model uses this covariance matrix to draw a function that satisfies the constraints imposed by the data and the kernel's properties. Key types of kernels in sklearn. Sklearn provides several built-in kernels, each with distinct properties and applications. Let's explore some of the most common ones. 1. RBF radial basis function kernel. Formula express x1 x22 to length scale 2. Key parameters. Length scale controls the smoothness of the resulting function. Smaller values indicate faster oscillations and less smoothness, while larger values lead to smoother curves. Behavior. The RBF kernel assumes that similar data points should have high correlation. It decays exponentially as the distance between points increases, leading to a smooth function that interpolates the data. Applications widely used in regression tasks and for modeling smooth, continuous functions. 2. Matern kernel. Formula more complex, involving Bessel functions. Key parameters. Length scale similar to RBF. Controls smoothness. Nu controls the smoothness of the function. Higher values lead to smoother curves. Behavior. The matern kernel offers more flexibility than RBF, allowing for different levels of smoothness. It provides a balance between smoothness and flexibility. Applications useful for tasks where the desired smoothness is unknown or needs to be adjusted. 3. Linear kernel. Formula x1 by 2 dot product. Key parameters none. Behavior. This kernel simply calculates the dot product between data points. It assumes that data points are linearly related. Applications suitable for tasks where data exhibits a clear linear relationship. 4. Polynomial kernel. Formula x1 by 2 candelas. Key parameters. Degree controls the polynomial degree. Higher degrees lead to more complex relationships. Coa zero constant term. Behavior models nonlinear relationships by projecting data into a higher dimensional space. Applications used when data exhibits nonlinear relationships that can be captured by polynomials. 5. Rational quadratic kernel. Formula 1 by 1 x22 to length scale 2 alpha alpha 1 2. Key parameters. Length scale controls smoothness. Alpha controls the shape of the kernel. Behavior combines the properties of the RBF and linear kernels. It's a more flexible kernel that can adapt to different types of data. Applications suitable for modeling data with both local and global trends. Combining kernels. Kernel sum. Sklearn offers the sum kernel, which allows for combining multiple base kernels. This is useful when you need to model complex relationships that cannot be captured by a single kernel. Usage. Python. From sklearn, Gaussian process, kernels import RBF. Matern. Sum. Kernel sum RBF length scale 1.0. Matern length scale 2.0. New 1.5. In this example, we combine an RBF kernel with a matern kernel. The sum kernel will add the outputs of these two kernels, resulting in a combined kernel that captures aspects of both individual kernels. Key YAML values explained. Let's assume you are working with a YAML configuration file for your Gaussian process model. Here are some common key value pairs and their descriptions. YAML. Kernel. Type RBF. Length scale 1.0. Optional parameters for specific kernel types. Degree 2 for polynomial kernel. Coa 0.1 for polynomial kernel. New 1.5 for matern kernel. Alpha 1.0 for rational quadratic kernel. Kernel type specifies the type of kernel used, e.g., RBF, matern, linear, polynomial. Kernel length scale controls the smoothness of the resulting function. Kernel degree for polynomial kernel controls the degree of the polynomial. Kernel Coa 0 for polynomial kernel constant term for the polynomial. Kernel.nu for matern kernel controls the smoothness of the function. Kernel alpha for rational quadratic kernel controls the shape of the kernel. Choosing the right kernel. Selecting the appropriate kernel is crucial for achieving optimal performance with GPs. Consider these factors. Data characteristics. Analyze your data for patterns like linearity, smoothness, or periodic behavior. Model complexity. Choose a kernel that balances model complexity and the risk of overfitting. Prior knowledge. If you have prior knowledge about the underlying function, consider using a kernel that reflects this knowledge. Conclusion. Sklearn's Gaussian process kernels provide a powerful set of tools for modeling complex data. Relationships. By understanding their properties, parameters, and capabilities, you can build effective GP models that capture intricate patterns and deliver accurate predictions. Remember to experiment with different kernels and combinations to find the best fit for your specific task.